Evaluating and graphing functions. We've already spent some time actually doing a little bit of evaluating, and we've graphed some functions. We're going to look at a few different types of functions than you've seen so far in these videos. Specifically, we're going to look at a cubic function, we're going to look at a square root function, and we're also going to look at an absolute value function. Your calculator can handle absolute value, as well as other types of polynomial, radical, rational, etc. functions. So we'll begin with example 1. We're asked to graph the function f of x is equal to x to the third minus 2x plus 1 in an appropriate window. Well, we'll begin by going into the y equals menu. Remember, we can always think of a function name as being the same thing as y. So we'll type in x to the third, and in this case we don't have a shortcut for the third power. So we'll just press to the third. At least we don't have one visible and easy to get to on the screen. You actually can get that character through the math menu, but it takes as many if not more keystrokes than just simply pressing the caret key and the third power. So there's x to the third. We're going to subtract, so minus 2x, and we're going to add 1. And I'll press enter. So there's my equation. I'm going to zoom to the standard window first and see what we get, if anything. So we'll let the calculator graph that function. What the calculator is doing is it's starting at x of about negative 10, and it is plugging those x values into the function, finding out what f of that value is, and then plotting on the screen where it can. Obviously some of these points fall off the screen. So this is not a particularly bad window to begin with. We're getting a couple of different curves here. It looks like the function goes off toward infinity on both the left and the right sides, toward negative infinity on the left, positive infinity on the right. If we want to see this in a little bit more detail, we could shorten up the x-axis. So let's try that. Let's take the window and let's see what happens if we set x min to negative 5 and x max to positive 5. It looked like easily for values larger than positive 5 and for values smaller than negative 5 that the graph was off our screen. So it was just kind of wasted space, if you will. So we'll rechange those two things only. X min, again, negative 5, x max positive 5. And we'll take a look at this graph again. And we get the same shape, but it's been kind of spread out to the left and the right. If we wanted to, it looks like we could bring in these windows even further, maybe negative 3 and positive 3. We could also expand the y to try to see more of what happens down there and leave the x's alone. There's lots of different choices we have for an appropriate window. But I think that one looks pretty good for right now. So what we're asked to do is determine f of 3 and f of 11 once we have this. Well, to determine a function at a given value of x, and that's what 3 is in this case, f of 3, we're letting x equal 3 and seeing what this expression on the right hand side is equal to. We can just simply press the trace button and then type in exactly the value we want. So I can type in 3 and press enter. And I find out that when x is 3, y is 22. So it's well off the screen here. My screen only goes up to positive 10. All right. That's a quick way to evaluate the function. Once we have the graph, now we're evaluating, and there's a quick evaluation. I can do the same thing for 11. I can type in 11 and press enter. But something's going to happen here. We're going to get an error. And we can either quit or go to on an error. Quit just means, okay, I screwed up, quit, I'm going to start again. Go to means I'm going to go back to where I made the error and see if I can fix things. In this case, this is not an error that we can go back to and fix. We're going to have to do a couple of different things to fix it. So we'll just choose option 1, quit. And this quits us back to this main screen here. The problem with evaluating f at x equal to 11 is in our window. If we press the window, we'll notice that the range of x values from negative 5 to positive 5 includes x3, so we were able to evaluate for that, but it does not include x11, so we weren't able to evaluate for that. When you press that trace mode and press an x value to evaluate, that x value has to be on the screen somewhere. All right, so in order to get to F11, what we're going to need to do is press enter here, and we need to make sure our x max goes out to at least 11. So maybe we'll choose 15, and then we'll press enter. All right, We know that y max could be a lot larger. We know it just at 3 that this got all the way up to 22. So let's choose something really big here. I'm going to try 50. That may not be big enough. Now it's interesting to note that the point doesn't have to be on the screen in the vertical direction. It's the x value in the horizontal direction that has to be on the screen when you evaluate using the trace function. Now here's a distance of 60 from ymin to ymax. I don't want 60 tick marks here, so I'm going to set my tick marks to be every 5. So I'll change x scale to 5. So here's my new window, xmin -5, xmax 15, so we include the 11, leaving x scale at 1, ymin left at -10, and ymax moved up to 50 with a y scale of 5. If we graph using this window now, we first get our axes, then we'll get a picture of our equation. Notice that these little bumps are getting hard to see, but we're not really interested in them right now. We're interested in 11, which is out here somewhere. Now 11, x equal to 11 is on the screen, even though the point isn't. So even though we can't see the point, we can still press trace, choose 11, and press enter. In this case, we get 1,310. So we could go back now and change our window to include at least that value for y max if we wanted to see more of what was going on up there at f11. But in this case, we just simply need to determine what the value was. So we know that f of 11 is equal to 1,310. All right. If we go back to the calculate menu, window for a moment, so we press second in the mode button for quit. There's another way to evaluate these functions as well. And if you press the vars key, which is very near the cursor keys, stands for variables, cursor 1 to the right to get the y variables menu. This allows you to get to a lot of the different variables that are built into the calculator. And the y variables are the graphing variables where we store our equations. So we'll go to the y vars here. Now there are 4 different function modes in the calculator. What we want to do is choose just one. We're always going to be working in function mode. Don't worry about parametric or polar. You might see those in a later class if you have to take more math. But we'll choose option 1 and we'll choose y1. Then what we'll do is we'll actually use function notation. So we'll put a 3 in parentheses here and press enter. And that's like saying f of 3, and we get back 22, which is what we saw before. One of the advantages of doing it this way on the calculator, on just the regular calculator screen, is you don't have to worry about how your window is set for the graph. This will work with any value. So for instance, if I repeated this by pressing second enter to get that entry back up, and then went back over top of the 3, and let's say that I typed in -7, which was definitely not part of that window we had. Close my parenthesis and press enter. You'll see that it evaluates that to -328. If we tried doing that in the graphing window, it wouldn't have worked because -7 was not part of our range. It was not on the screen. So there are 2 different ways to evaluate functions once you have them entered into that y equals screen. All right, let's go back to the y equals screen now and talk about example 2. Here we want to graph the function g of x is equal to the square root of x minus 5 in an appropriate window. So let's clear out the function from example 1 and let's type in the function for example 2. So we get a square root by pressing the second key and the x squared key, which has a square root symbol or a radical immediately above it in the same color as your second key. That opens up a square root in parentheses. We type x minus 5, close parentheses, and press enter. So that says that we want to take the square root of everything in parentheses, and that's x minus 5, which is everything underneath the radical, as seen here in example 2. So I'm going to zoom back to the standard window and see what we get, if anything. Sometimes when you zoom to the standard window, you don't get anything, and then you've got to work to figure out what's going on. But a lot of times if you start zoom standard, it gives you an idea of a place to start when you're playing with the window. Now here we see that the square root of x minus 5 graph appears to start at about +5 on the x-axis, and it goes up into the first quadrant. So most of the graph here in the second, third, and fourth quadrants isn't really required. So let's take our window and let's let x min equal 0. And let's extend x max a little bit. Let's maybe make that 25. we saw that we were quickly getting off the edge of the screen to the right. And I'll leave x scale at 1. I think that's going to be okay in this case. Y min I'm also going to be able to set to 0. And I'm setting x min and y min to 0 because that gets me to working in the first quadrant only. And we saw that our graph only existed there. And y max of 10 is probably still fine. So we'll leave that alone. And we'll press graph. And here we have our picture. So what we're doing is we're taking an x value, subtracting 5 first, and then taking the square root. The reason we start at 5 here is if we tried to take 4, for instance, 4 minus 5 is negative 1, we can't take the square root of negative 1, at least not in the real numbers. So the first number we can use is 5. 5 minus 5 is 0, and the square root of 0 is 0. And then as x gets larger, we get to points where we can take the square root better. We're going to evaluate. And we're going to evaluate here on the screen just for simplicity's sake. We have both 3 and 14 on our x-axis. This x-axis goes from 0 to 25. That's what we set up on our window. So I'm going to press the trace key. And I'm going to type in 14 first, since that's the first thing it asks me to do. Press enter. And the calculator comes back and tells me that when x is 14, y is 3. And if you substituted directly, you could see that 14 minus 5 is 9, and we know the square root of 9 is 3. So that makes perfect sense. The next thing that we're asked to do to take the function value at 3, well, we've already noted that 3 doesn't make a lot of sense. So what happens if we try to type that in? Well, we'll press 3 and enter, and it just tells us nothing. All right, this means that for x3, there is no point on the graph. And again, the reason for that is that you'd end up with a complex number, and we can only graph real numbers on the plane here in this window. So we didn't get an error, which you might have expected, and we would in other situations trying to take the square root of a negative number on the calculator. In this case, we just simply got back nothing. So there is no pairing for x equal to 3. All right, in example 3, we want to graph the function h of x is equal to the absolute value of 2x plus 3 in an appropriate window. And we're not asked to do an evaluation for this example, although we easily could using the methods we've already discussed. But let's go back to the y equals menu. Let's clear out the function from example 2, and let's type in this function. Now the absolute value function on the calculator doesn't involve the usual absolute value symbols, those vertical lines to either side. In order to get absolute value, what you're going to have to do is press the math button, and then you're going to have to cursor one to the right. You'll see that the math, when we get into math, we have 4 different submenus: math, num, CPX, and PRB. This is math, numbers, complex numbers, and probability. If we cursor one over to the numbers, the very first thing we get is ABS, or absolute value. So we're going to choose that. And we want the absolute value of 2x plus 3. So we're going to type in 2x plus 3. And we'll put a right parenthesis on there. We want to take the absolute value of everything between the absolute value signs in our example. So we want everything in parentheses with the absolute value function there. I'll press enter, so we get that stored into y1. And then I'm going to zoom option 6 or zoom standard again. And we'll let the calculator draw the graph of the absolute value of 2x plus 3. And there we see it. We see a big V, which is typical of absolute value functions, at least of the absolute value of linear functions. And one of the things you'll notice is that this graph does not extend below the x-axis at all. And that makes sense because the absolute value of a real number is always 0 or greater. It can never be negative. So we don't get any negative y values here. So one thing we could do to change our window is to bring the window up so that y min is 0. Makes better use of the space we have and doesn't graph anything in a place where we know we won't have it. So I'm just going to change y min to 0 here in the window screen. And once I've done that, I'm going to press graph again. And we'll see the graph come down. It's going to hit the x-axis, and it's going to go back up again. Now from here I could also change the x-axis to see this V differently. I could extend the y-axis up depending on what I needed to do. But this is a pretty decent window for the moment. It shows us everything that we need to see about this function. So there's a bit about graphing, appropriate windows for graphing, and some tips and ideas for evaluating functions once you have them entered into that y1 or excuse me y equals menu.